Hi, this is Thomas. Welcome back. Our topic is trigonometric identities. This is example 2. Our requirement, find the exact value of sine 15 degrees. The algorithm. Step 1, identify scenario, equation, or identity. We're going to set up an equation. Sine 15 degrees equals. Now, what is on the right side of the equation? That is step 2, identify relevant trigonometric identity. We know exact values for sine 30 degrees, 45 degrees, and 60 degrees, so we have two different options to subtract with exact sine values to sine of 15 degrees. So we'll set up our equation as sine A minus B. So we're using a compound angle formula. Sine with subtraction. We've completed step 1, we have our equation. We've also completed step 2, we've identified the relevant identity. Moving on to step 3, we will substitute. The right side of the equation is either 60 minus 45 or 45 minus 30. Sine of 60 degrees minus 45 degrees. From here I'll apply the identity. And that identity is, and if you don't know the identity, you'll have access to the formula book to look it up. When we're using the compound angle formula with sine and subtraction, then our setup is going to be sine A times cosine B minus cosine A times sine B. In this case, that will be sine 60 degrees times cosine 45 degrees minus cosine 60 degrees times sine 45 degrees. And now, having used the identity, I'll move to step 4, simplify to solution or desired expression. So the right side of the equation will be sine of 60 degrees, which is root 3 over 2. Times cosine 45 degrees, which is root 2 over 2, minus cosine 60 degrees, which is 1/2, times sine 45 degrees, which is root 2 over 2. I can simplify to root 3 times root 2 is root 6 over 2 times 2 is 4, minus 1 times root 2 is root 2 over 2 times 2 is 4, which will simplify to denominator of 4 and numerator of root 6 minus root 2. And here we have the exact value of sine 15 degrees. And this concludes trigonometric identities, example number 2.